three types of heating in a commercial application. Well, actually, I guess we can consider it four. There is electric, gas, what would you call a heat pump style heating?
You can consider it, I mean, it really is its own heat pump.
Right. Yeah, we'll just call it that. That works for me. You're not speaking my language, so we'll just keep it simple. I'm getting into gas stuff there, and I don't do the thermodynamics expansion nonsense. It's all voodoo. So there's four basic types of heating in a commercial application. We have electric heat, gas heat, hydronic or water, and a heat pump. Typically, they are all controlled in a similar fashion, although they have a little bit different algorithm, I guess is the best way to put it. Staging and separation of stages and cycles per hour, that kind of stuff is going to be different between each one. But yeah, other than that, they're pretty simple. Electric heat, there are two kinds of electric heat. There is staged and modulating.
It'd be the same thing for gas, wouldn't it?
Yeah, that's what I'm thinking. I'm trying to think, because I'm trying to think of have any applications where we control a burner. Usually it's just a simple on off.
Yeah, you're just firing the load.
Yeah. Yeah, we don't, I'm trying to think if there's any that I send a 0 to 10 to that we've done, or even a 4 to 20 or any, I don't know of any applications where we modulate gas. I have had one with multiple gas burners,
Oh, yeah.
but not, it's still just a staged control. So I don't know of any that I have, you know, like it's got multiple elements.
Right.
Yeah. So let's stick with staged. So. All right. Water control is one of the weird ones. It can also be not necessarily staged, but we can call it on-off control. I've never really had I don't think I've ever had one that's got multiple hot water valves. It's pretty, that would be a weird scenario. I mean, I guess you could consider like a multi-zone unit, but each one of those is independently controlling a space, so.
Yeah, you're still talking about individual.
Yeah, yep, no, so yeah, it's gonna be on, off, or modulating at that point. All right, and then the heat pump is gonna be actually, let's take that back. No, because it can be modulating.
Yeah, but does the automation modulate it or is it onboard control?
On both.
Yeah?
Yeah, I've controlled it with a 0 to 10.
Interesting.
Yeah, it had an Aeon that we gutted. The VCX controller went bad in it.
Yeah.
Yeah, that was an interesting one on the surgery suite in Houston.
So was that running heat pump or was that just reheat?
Oh, Oh, you know what? That was high gas bypass. It
Yeah.
wasn't a heat pump.
That would have been reheat.
That's a good point. That was.
So you're gonna start really losing me, you start talking about modulated heat pumps.
No.
You already lost.
You're right. You're right. That was just high gas bypass. It was not a heat pump per se.
Right.
Yeah. Okay. So we'll stick with stage then. All right. Do we know the difference in staging and modulating, or do I have to go into that?
I think it'd be worth covering.
Okay. Yeah, we'll cover it.
At least on a basic level.
Yeah. So, staged heating or cooling, for that matter, is going to be either on or off with multiple stages of on or off. So if you've got two compressors, we would have two separate signals that the controller drives to bring them on, 1, 2, in sequence or in a staged application. You can also have, to really throw a wrench in it, staged stuff driven off of a modulating output. They have those little sequencer boards that take a 0 to 10 input, and based on dip switches or dials on the board, close relays. No, some outside air units that have that here that we deal with. But yeah, so stage is going to be an on-off control of the compressor. As your temperature drops and your load increases, you would bring on additional stages at that point if you have them. Some systems are single stage, some systems are multi-stage. Just depends on how it's configured, what kind of equipment it is. Modulating is a signal proportionally controlling your equipment. So it would be like a 0 to 100 percent output. So, and then that can be either a 0 to 10 VDC, a 2 to 10 VDC, a 0 to 5 VDC. I mean, in theory, it can be anything in that. It can also be a 4 to 20 milliamp. It could be the DC one gets real squirrely because it can be anything in a DC range. Like I can define it as a 1 to 3, I can define it as a 1 to 5. I can, depending on what kind of equipment it is, I could theoretically take and limit the output of a system. Say the sequencer takes a 0 to 10, but I don't ever want all 5 stages to come on. I could limit my output to a 0 to 5 and only get half the stages. I don't know why you would do that, but in theory it's possible. So modulating is more precise control, gives us kind of a curve instead of having just a simple on-off. In this case, it would be a SCR relay that would basically, an SCR controls the amperage going through the contact to vary the amperage of the heater. So how much current it goes through it determines how much heat it puts out. The more signal you give it, the more current it allows, the higher the heat output. Water would be a 0 to 100% on a valve. You open or close the valve. The more you open the valve, the more water you get, the higher the temperature. The deal with water is not all valves are modulating. Some of them are simple on-off, where it's either open or closed. You either got no flow or all the flow. Some of them are, actually, hang on. We'll go back to, take a step back. It'll be over within 10 minutes if I don't take a step back. be sorry for my handwriting. All right, back to the electrical. So staged is an on-off control of a heating element. Modulating is a variable output.
So that'd be like an SER.
Yes. So modulating is a variable output of a heating element. Like I was saying, 0 to 10, 4 to 20, 2 to 10. Basically, it could be where you are controlling an SCR, or it could be with a stager. So an SCR, like I said, is going to vary the amount of current that's allowed to go through the heating element, whereas a stager would bring on multiple on-offs via a 0 to 10 signal. So then we'll go to gas. Will be staged. Same thing, on-off control of a burner. So the stage control would be on-off control of a burner. You're starting a gas burner, basically. Most of the time with gas, we have very few safeties are actually in the control circuit. Most of them are in the gas system itself. We usually just close one set of contacts to start gas heaters. Whereas like an electrical will have an airflow switch or something along those lines that are actually tied into the automation system to kill it. These actually just, they do everything on their own and they don't actually interrupt our signal most of the time. I guess I should have touched on that with heating as well, the electric heat. Man, just a discombobulated mess today. Yeah. Gas systems tend to start the heater first, then the fan, and you shut the heater off and then leave the fan running. It's to keep you from getting a big blast of cold air when the fan first kicks on and the heating element's not running. And then it's also to remove the latent heat from the burner system once it shuts off. Kind of just a longevity of the system type control. Yeah, and gas is pretty simple. Just turn the valve on. Pilot light, pitot, all that stuff's built in.
How would you set up like a control sequence for, say, a couple of boilers on loop?
Okay, well, so that, I would consider that hydronic then. Yeah, I was gonna hit that when I got to the water side.
Okay.
Yeah, so, yeah. Jumping the gun, Paul. Jumping the gun. That's the one that's gonna take the most dive into, right? I mean, cause it's, in our world especially, because we deal with a ton of water systems, but in commercial applications.
Well, I guess a typical gas application for automation would be what, like
A rooftop,
heater
a package
or-
unit, yeah, I mean,
Or say like just the gas system, like it would be what, like a heater for an equipment room or something? Like what would you say?
no, it'd be some package units, RTUs, that kind of stuff. Maybe a unit heater, if you want to talk about like a standalone gas heating system, you could have that. You know, like those 120 volt or 277 volt or 480 volt electric heaters. It's just a fan and an element. You can have the same thing with a gas system as well. Just like a space heater, basically, forced air. Those are super simple. nothing a lot, not really much to them. Yeah, I mean, we don't, in all honesty, most of the time when you have those type of heaters, they're usually not even connected to the BAS. We do have some that are, I'm not saying they're not, but a lot of times they're standalone. Especially if they're doing like one of the things you used to always run into in the big flat fan systems was they would have those in the outside air chase to help warm up the air and keep the coils from freezing when everything was shut down, that kind of stuff. And just on wall stats, man, they're super simple line voltage or whatever. Rarely did we ever control them. We do from time to time. Like I know, actually just went out and troubleshot one the other day that was in a pump room on a roof. Just a little small electric, I think it was 110 volt, little tiny guy, but it had a communicating wall thermostat on it. So just standard on off W1 G type control with a communicating interface on the thermostat though. So no programming on our side. It just gives us a readout basically. Yeah, I don't know. The gas and the electric stuff's pretty easy. It's the water stuff that gets complicated.
Well, unlike the electric, how would you decide, so say you're on either way you go with it, whether staged or modulated, how would you decide a control sequence on that? Like how would you, in layman's terms, how would you write that sequence so that, you know, say you're dealing with a fan power box, right? And you want to control.
Yeah. So, all right, we'll give you a peek underneath the veil. I don't write control sequences, engineers do. No, in all seriousness though, like we try not to ever write a control sequence per se. We either take whatever's existing in the building and use that, or an engineer would provide it. If we do end up in a situation where we are writing a control sequence, we usually get the customer to sign off on it, that kind of stuff, because we're not engineers. So, I mean, just one of those things. But to what Holden was speaking about, as far as the controller's sequence of operation, once I've...
That's a different question.
Oh, okay. Sorry. Once we have determined a sequence of operation for the box, programming it is pretty straightforward. But the way a fan power box or VAV would work, even regardless of if it's staged or modulating, there's two types of fan power boxes. There is a series and a parallel. So that is the biggest difference in the two kinds of fan power boxes you will encounter. Series, your fan will always be running. Your fan runs constantly. Okay. Fan runs heat only. Okay. The two types of boxes that you have to consider in fan power boxes are series and parallel. A series fan is going to run constantly. The air is in series through the box. It comes in through the inlet, through the fan, out the box. In a parallel box, you have an inlet and a fan that can both supply air to the medium pressure duct. Kind of draw out a quick, dirty example. So this will be a series box. So in a series box, this is your air coming in from the supply duct. Air comes into the supply duct, pressurizes the cabinet. If the fan is not running, everything will escape from the side pocket, or the return, whatever you want to call it. It has to pass through the fan to get pushed out of the box. If the fan's not running, what you'll see is a lot of air coming out of that side grill, pocket, box, whatever you want to call it, on the unit. A lot of times we come to systems that someone has gone and turned the fan off because it was too loud or noisy or making a noise, and then they wonder why the space gets hot or cold. Well, your air is just coming right out into the plenum. If you have a ceiling, it's going to cool your return plenum. If you don't have a ceiling, it's just going to fall down in the space and overcool the space. Once this fan is running, this will go neutral when your damper is at its full control signal. Not necessarily full position, because boxes modulate airflow, not temperature. So what happens when they do an air balance in a job after we have installed controls is the test and balance guys will come through. We command this damper to its full flow value, which may be, say you have a box that can physically do 2000 CFM, well it may only be designed to serve 1500 CFM. So we would run it up to the full 1500 CFM, then they balance this fan to where they reach a neutral on this pocket. So they have a little potentiometer in the fan that you can turn the speed up and down to where this becomes neutral. It's not positive or negative, it'll like flutter a piece of paper. It's no pressure and no negative. What then happens is this damper modulates, it will start to draw air in from the return, mixing plenum and supply. And kind of, that way it's not like, you're not getting like full 55 degree supply air and you're not getting full 74 degree return air. It mixes the two. So you may end up with 65 degree air going into the space. I like series boxes for 3 reasons. A, the customer does not experience a fan turning on and off. They don't hear that noise difference, which is a huge deal in these big buildings, especially now that they're going open ceilings and stuff like that. They hear the noise. Number 2, even though you have more motors per se in a building, they are fractional horsepower. So they actually use less energy than the big fan blowing air into them. You can take what would be a 40 horsepower air handler and drop it down to like a 20 when you have series boxes, because you don't have to supply as much pressure. And then you have fractional horsepower motors throughout the building, which draw almost no amperage. So they're more energy conscious, and you get the effect of your tenants don't get blasted with 55 or 100 degree air. It can mix that air based on the temperatures in the space. So what would happen is this box would modulate to its minimum position for flow, which typically you're always gonna have like 10% flow in heat. That way you're still circulating air. And then it'll start drawing in air from this plenum. It'll push all that out of the box and then fire your heaters. And that's the standard operating procedure of a series box. A parallel is a little different. So a parallel box has 2 chambers. So the way a parallel box works, and parallel boxes are kind of cool. Some of them, your heaters are draw through, and others, they're push through on the boxes. So they can be in both places. It really doesn't matter either way. the majority are gonna be pushed through. But the way a parallel box works is you have two separate cabinets, basically. They're parallel to each other. You have a fan cavity and a supply cavity. They then, either one can pressurize the cabinet. And then what happens is the fan will have backdraft dampers on it. That way you cannot push air through the fan out into the plenum. So either the supply duct pressurizes the cabinet or the fan pressurizes the cabinet. In a parallel box, when the unit is requesting heat, it will shut the damper or modulate it to a minimum position, start the fan. And then the fan will run to its set airflow and the heat will then kick on. It uses kind of like, think of your fan as your first stage of heat. It'll draw return air that's warmer than the space air and push that down to the space as your first stage of heat. Some boxes, depending on how it's specified, will do both at the same time or independently. Majority of the time it's fan first, then heaters. Where are they going with that? Yeah, so that's your two kinds of boxes and how they function. Fan power boxes can be hot water or electric heat. They can also be staged electric or they can be modulating electric. 9 times out of 10 this can be an SCR. You might find some really old ones that have sequencers in them, and it's been somebody that had a controller that had a 0 to 10 and doesn't have a BO or something, or it didn't have enough BOs for the heaters. Like if you have a parallel box that has a fan and 2 stages of heat, well, they may have only had 2 BOs and an AO, so they used the BO for the fan and the AO to drive the 2 stages of heat through a sequencer. It's kind of like, all right, I don't have enough controller outputs, I'll do this with a sequencer and get it to work. I've actually seen that a lot.
I think we've got a lot of old buildings. The majority of what we service are still, I think, binary or staged.
Yeah.
I think a lot of what's going in are SCR.
Yep, definitely.
We don't have very many new buildings that we do routine service.
Yeah.
Yet.
Yeah, that's true. Well, I mean, because a lot of the buildings that we've done were pneumatic, and there are ways to do modulating outputs with pneumatics, but it is complicated, you know? Yeah, you have to have an E to P, or a P to E, a pneumatic to electronic transducer. So it takes your 9 to 13 and converts it to a 0 to 10 or a 4 to 20, and will then drive a heater that way. They're not hard to set up, it's just you're adding in extra components. Like if you're gonna go that route, those things are $200-300 sometimes. You might as well just put a controller in it. So, but doing that in one box in an entire building of a pneumatic system is not beneficial. They'll usually just put a PE in it and call it a day. So, yeah. Any other questions on VAV fan power boxes? So general rule of thumb, the way it works is your fan has to be on for heat, no matter what, because they typically have an airflow switch in them that requires positive pressure to engage the heater. So fan always has to be on for heat. Very few systems will have the ability to run the heater without the fan on in a fan powered box. There are VAVs with electric reheat or hot water reheat that it doesn't matter. They will be programmed to maintain a minimum CFM through the box, which is enough to trigger that airflow switch. So like if you have a VAV box, I know we did a couple downtown the other day, a couple months ago, like 3 or 4 of them did. The minimum the engineer specified was too low to bring on the heaters. So we had to up the minimums, which meant we had to go get an freaking RFI and get it approved and all. It was a nightmare. But because somebody didn't do their homework and read the minimum airflow value on the box to make the heater, you know, it is what it is. We're all busy. I can't talk too much smack. I miss all kinds of stuff. But yeah, so series box, your fan will always be running think of it kind of as, we'll just call it a mixing box, right? You're constantly mixing supply and return through a series box. Parallel is pretty much either or. Your damper's gonna go to a minimum and your fan's gonna kick on. That minimum may still be 10, 20% depending on what the engineered value is, but it can also be 100% airflow value and no fan in cooling mode. Whereas in a series box, the fan is always running. You're always modulating between your high and low value for set point, for airflow, and the fan makes the rest up through the plenum. Yeah, so that's that on that. The hot water boxes are a lot easier because they don't have airflow switches. It's just hot water. No need to be safe. You're not gonna burn anything up with hot water. Anything else about sequences on that, or does that make sense?
Not great.
Yeah.
Everybody's good?
I like. Yeah.
Okay. You want me to jump back into electric heat before I touch on hot water? I don't know what else to say about it.
Fans usually done.
Yeah, I mean, it's pretty,
I think it's well covered. The only thing that we hadn't gone into detail on is like the deviation from set point, but
okay.
I mean, it's
Yeah, we
pretty
can,
straightforward.
yeah, I mean, we can touch on it. So, do a, actually, you know what? I don't like that kind of graph with this. We're gonna go like this. All right, so we'll go. Okay, so. All right, so this is, most systems we deal with will have a heating and cooling set point that are separate of each other internally. You may see it as one set point. It may show up as a center set point or a common set point or room set point, whatever it's labeled. It's still gonna have a heating and cooling set point. It may just be maintaining a differential based on that center set point, you know, plus or minus 2 degrees. The idea of that is that it wants to maintain between those two set points. So as your space temperature is in the middle, it's what we would call satisfied, right? It's gonna go to either a minimum flow position or a minimum heating position, whatever the last mode it was in. And this is one that throws a lot of people off. You walk up to a space and it can be, let's just say the space temperature is currently 73.5. We'll just throw a weird number out there. And that box may still be in heat mode when you look at it. Well, it's in heat mode because it had gotten below or close enough to 70 to trigger a toggle in the mode, and it has not gotten hot enough to trigger back to cooling. So it's satisfied. It just doesn't have a satisfied. Honeywell's real bad about this. So Johnson has a satisfied mode, right? This tech can say satisfied. Honeywell does not have satisfied. Honeywell is heating or cooling or off.
So it's constantly.
So no, it's, well, I mean, yeah, everything's constantly up and down, right? It's, you're always trying to maintain that middle ground. It's, with outside factors, you're never gonna get a constant, steady, never changing temperature, right? You've always got a heat influx or a cold influx. So your temperature's always doing this. You're always chasing that wave. So what throws a lot of people off is that they come in, they see, well, my cooling set point's 74, my heating set point's 70, but it's 73 in the space and the box is in heat mode. Why is it in heat mode?
Not really.
It's not really in heat mode. That's the last mode it was in. It just has not toggled in to cooling yet. So it's not necessarily actively heating the space. It may be at its minimum heat flow set point, which is 9 times out of 10, the exact same thing as your cooling minimum flow set point. It's usually 10 to 20% of the total box flow is your minimum on a VAV or heater or fan power box. Different systems vary and different buildings vary, even with the same systems, where that trigger point is to flip modes. Some of them won't toggle into cooling until it breaks 74 degrees. Some of them will do it a degree before at 73. Some of them will do it at 72. It just depends on how that system's deadbands are configured. But just because you walk up to a box and it says it's in heat mode and it's a degree away from the cooling set point, don't freak out. If you need it to cool, drop the cooling set point down below the temperature, and if it doesn't immediately flip over to cooling, then you have a problem. You know what I mean? So like if you walked in here and this was at 73.5 and you need it to cool, I would drop that to 72. If it does not toggle to a cooling mode, then there may be an issue with the program.
Time delays with that, or is it an instant thing?
It's pretty quick because they're proportional algorithms, right? They're like I said, they're chasing that wave. The further you get away from a level line, the faster it reacts. It's proportional, okay? And it's proportional over time. The longer you sit closer to that peak, the faster it reacts. So it varies based on time and differential. So if you are staying hot over a long period of time, it will continue to increase your cooling command.
So you're saying blowing on the thermostat is not really a great way to test that.
I mean, yeah, it can
You
be.
get to go to cooling.
Yeah.
If it's like at 71, I'm blowing on the thermostat trying to get it hotter, because it's reacting so quickly.
It can.
Okay.
Yeah, no, 100%. You can, a lot of times you can put your hands over a thermostat and do like this into it. You have to do it for 30 seconds or a minute, but it is a way to trigger it on. But if you have access to the system, I would drop the set point. That's gonna be a lot better. No, it's not. I'm fully with you. And that's why I'm saying the little cup the thermostat and blow into it.
Keep my back on it or something similar
Yeah.
to that, yeah.
That typically takes a little longer, but yeah.
Also look like an idiot blowing on the thermostat, so.
I mean, you could just sit there and rub it real fast for a little while. That looks even weirder. Especially when it's one of the little dots on the wall. So back to what I was saying. So just because you are really close to your cooling set point doesn't necessarily mean it will be in cooling, okay? The premise of the box is to stay as close to between these two set points as possible, okay? The closer it gets to this set point, the better chance it is in cooling. The closer it gets to this set point, the better chance it's in heating. But if it's in between those two numbers, it can be in either mode. It doesn't matter what brand it is, it can do it. I've had Distech systems that will do that, JCI systems that'll do it. Sometimes they say satisfied, sometimes they don't. It just depends. There's so many settings deep down in the core of the program that affect the way that little bit functions. It's hard to tell you that, hey, JCI every time will do this. Honeywell every time, because there's so many parameters that we can adjust to fine tune that stuff. So, but like I was saying, every system will have a heating and cooling effective set point, regardless of whether it's working off of a common set point, let's see, what else do they call it? Common, room set point, zone set point, like there's a bunch of different names. Different people call it different things. But think of it as temperature increases and gets closer to this, you would toggle into cooling, right? Which would then open up your air valve or start a compressor or whatever it may need to do. As it comes back down, oh, here, I'll touch on that real quick. So this is what we call a direct function or a direct PID or direct algorithm or whatever you want to call it. It's direct. As the temperature increases, your output is going to increase as well. So it's directly proportional to your control. So the further you get away from set point, the more that box is going to increase its output to try and get it back down, okay? So as it gets back in here, it would satisfy, and then when it starts getting in heating, it's opposite. The further you get below your set point with your control point, it would increase. So as this number,
Absolute value.
yeah, it's all relative, but this is a direct acting and this is a reverse acting, right? As temperature decreases, your output increases. In cooling, as temperature increases, your output increases. So it's like reverse acting thermostats versus direct acting thermostats, right? Reverse acting is heating, direct acting is cooling. So yeah, just to touch on that. Kind of makes sense. The main thing I wanted to focus on was just because it's in the middle of those, don't expect it to be one or the other. We fight with that a lot. And some boxes will, even if it's, so parallel boxes, we deal with this a lot. They could be running the fan in this section, right? So it's satisfied, but it's in heat mode and the fan's running. And a lot of customers that drive nuts because they're like, well, it's super loud. The customer hears the fan. Why is it in heat mode? It should be satisfied. Yeah, I wish. That would be awesome. Unfortunately, the way that algorithm works, the heat runs whenever it's in heat mode, right? Because that's your first stage of heat. It doesn't care if it needs active heating or passive heating. That fan is on because that's in heat mode. It brings the fan on. So there are ways around that. We can program that out of stuff, but a lot of systems, that's a default logic in it. And we don't really, it's not that we don't like to modify those programs. The manufacturers are not as willing to help us with technical support if we modify their programs. So 9 times out of 10, we use a default program from the provider, from the like Honeywell or Distech or Johnson. Johnson is really bad because for us to write a program in Johnson I'd rather pull my teeth out with a pair of channel locks, okay? Johnson is great. It's a super powerful programming tool, but it is convoluted and unfriendly. And Johnson are what we call application specific controllers. You buy a VAV box, it comes with a VAV box program in it. You just configure it, okay? The Honeywell programs are the same thing. They just don't come with the program preloaded. You have to select the program you want that fits an application, like a VAV box or a fan coil unit or whatever, and then you drop that in there, and then you configure it to fit your application specifically. Distech, same thing. They all offer a factory debugged and programmed and all that stuff, and then you just configure it and say, hey, it's got this much flow at this and this much flow at that, and you set your set points. It's got 2 stages of heat, 1 stage of heat, a fan or no fan. It's like checkboxes, right? And we don't have to program them 100%. They already have an application in them. You just have to define that application for your needs. The benefit of that is that we get full factory support on that. So if there's a problem with that box, they'll log in, they debug it, they help us troubleshoot it. We can send them screenshots. It helps us with troubleshooting a lot, right? Because we didn't write this program, so we don't know it super well, because it's crazy. And if you modify it, it can break a function, and then they don't want to support you anymore. And in reality, there's only like 5 kinds of VAV boxes. So you can build a program with 5 optional things, right? And you can make it toggle between what functions it does. There's no point to rewrite the book. Like, it's done. Like, I've been using this. Right, exactly. So literally minus some small bug fixes and things like that, the programs that have been out when the current controller line was released is the same program we're still using, right? There's nothing wrong with it. It's programmed, it's debugged, it's tested, it's vetted. It doesn't need to change. There's not a whole lot in a VAV or fan part box that's gonna change in the way it functions. So a lot of it is the application of it, not so much the programming of it. So, but we try not to mess with them if we don't have to. But if I end up with a problem box where like, oh, this lady's always complaining because the fan's running, even when it's not, doesn't need to be in heat mode, we can turn that off. I just would only do it to that one box unless they request to do it to all of them. And then we know, all right, I messed with that one, I own it type deal. So, yeah. All right. You want me to dive into heat pumps, or do we just leave that as stage control and call it a day? Whiz bang wizardry, man. I don't.
Well, just heat pumps, it's
No,
such a, other than you giving a start command.
Yeah, there's. Yeah.
That's all we ever see.
Yep. Yeah. It's exactly. I agree. Okay. All right. I'm gonna erase this because we're gonna need room for activities on this next one. All right. MacGyver.
I got a tool bag.
What about MacGyver?
It's the guy for 50 cents.
Oh.
I can't sit still, so since I'm not teaching, I have to find something to
We all have a toy in our pocket.
keep myself in motion.
I get in trouble with this one. People are like, what is that? And then they realize I'm like, why are you doing that? I'm like, it's just a nervous tick. I freaked Ivan out one day. He walked in the office and I'm like, he's like, you all right? Oh yeah, sorry, my bad. Okay. Yeah, exactly. Okay. Holden, this is where I stuff up. All right, so I guess we'll start with explaining the components of a hot water system first. Okay, just to get a general basis. We have, don't judge my drawing skills.
So far, so good.
So better than you think,
Okay,
compared to the rest of it.
and then hot water pumps usually on the supplier return.
Normally on the leading side of the pump, so you're not putting the hot water, the hottest water through the pump.
Right, but on the supplier return of the coil.
Let me see my outlet according to our pump class.
Is it the boiler or the valve?
No, the valve. No,
Oh,
the
leading
pump.
side.
So return, right?
Yeah, the leading side of the coil is where your valve.
Yeah, well, I know that, but, so then it would come into the pump and then into the boiler and then out, hot water into it, right? Okay, hey, I'm just, hey man, I'm thinking
Trying to
here.
teach us correctly.
Right, exactly, I don't wanna tell
I
people
feel it. I
incorrectly.
appreciate it.
Okay.
appreciate it.
I know that there are systems that the pump is on the other side,
Oh yeah, I do too, I mean,
but it's supposed to be on that.
yeah, that, I'm this I was comfortable with. It was this that I'm like, all right, are we like, I know the valve is on the return, that's a given, but I didn't know if, yeah, all right, so it has to be there because you're not pumping through hot water. Duh. Okay. What else could we do? I guess. All right, let's do a. We'll cut in one of these too. Why not? The marker's dying, Holden. Can't even get decent. Ooh, that's serious. Okay. I'm drawing these two in black. All right. So.
So when you're done with this, leave it up there for me.
Okay, yeah, okay. I was starting with a boiler. There are multiple other heat sources in a system for hot water. You can have a boiler, you can have a heat exchanger, you can have solar thermal, you can have, I mean, there's anything that heats water up.
They have
Right.
solar thermal to govern.
Yeah, I know.
It's cool.
Yeah. You can also have gas boilers, you can have electric boilers. I'm not gonna get into all that. We're gonna focus on it as a heat source. Then you have obviously a pump to circulate the water through the system. You have a coil, which would then take and transfer the heat from the water to the air flowing over the coil. You have a valve, which controls the amount of water going through the coil. And that's the basic parts. There are and can be two other kinds of valves in a hot water system. There can be a bypass valve for the boiler, and there can be we'll call it a bypass valve for lack of a better term, that maintains differential pressure in the system. So coils are designed for a certain amount of pressure across them. You can have a valve that modulates open or close to maintain that pressure in the loop to keep your coils at their most efficient differential pressure.
And that would be different than a three-way?
A three-way does the same thing, but a three-way is a set GPM. So a three-way valve, no matter what, you're circulating the same amount of water because it either bypasses the coil and continues back into the system or goes through the coil. This is, I guess, the same thing too, but
It's focused on pressure.
right, it's focused on pressure versus GPM. So that you would have, what you would have here is you would have a sensor and a sensor, or a pickup and a pickup that then come to a sensor. This sensor would monitor the differential pressure of the loop, feed that back into a controller, which then modulates the pump or this valve to maintain differential pressure. Typically, like you said, the valves are constant volume. When you modulate the pump, it's variable volume. So very few systems I've encountered have variable volume hot water systems. They're usually constant volume and we're just maintaining differential pressure. That being said, it is possible, I guess, to do it because it's water and there's variable volume, so why not? The bypass valve for the boiler would be to limit the amount of water going into the boiler or to shut the boiler off when it's not in use, to not circulate water through it. If you have multiple boilers, sometimes it'd be like an isolation valve in that case, where you could shut off this boiler and only push water through the one boiler. That way you're not sending water through a boiler that's not being used. It can dissipate heat that way because it's a heat exchanger. So it can also cause condensation to build up on the tubes, which causes corrosion. Multiple reasons to have a valve at the boiler itself. Some systems are two-pipe systems that have the same water goes through the system, whether it's heated or cooled. So you would have to isolate your boiler so that you don't pump cold water through it when you're in your cooling cycle. And it's called a changeover valve at that point, instead of a bypass valve. As temperature outside varies and you're in your cooling mode, it would open up, send water through your cooling system, whether it be an air-cooled or a liquid-cooled chiller or heat exchanger or whatever. It shuts off your boiler, sends it through there, that sends it through the coil, the system knows I'm in cooling mode, it cools. In hot water, it would do the same thing, but vice versa, open up the boiler, shut the chiller, modulate to maintain heat at that point. Yeah, it's pretty much, where was I going with all this? Okay, so in a hot water system, there are, like I said, there's differential pressure, which is maintained by a valve. Most systems that have a three-way valve, like Holden was talking about, are not maintaining differential pressure. They may be maintaining differential pressure as well as having a three-way valve. That's when they get real fun. But most of the time they do not, because they're constant flow. So constant flow meaning your gallons per minute or hour never change. The pumps run at a set value. It's always circulating X amount of water, no matter what. The ones that have a bypass valve and maintain differential pressure still do the same thing, where your pumps run at a constant volume, but instead of having a three-way valve up at the top of the system that allows the loop to go either direction, you would have so in a three-way valve, this valve can open up and either let water circulate through it, or it can close and push water through the coil. In order to maintain that constant flow, if this valve were to close and this valve were to close, you have no way to flow through the system. So a three-way valve allows water to bypass and continue to flow through the system. Pretty simple. We have it in chill water, we have it in hot water. It's a pretty standard thing. Can you see all that on there, Holden? Okay. Just didn't know if my drawings were visible enough.
Reading the comments.
They're saying I'm an asshole, idiot. What are they saying? Do I look cute today? My nipples hard? What do we got?
No, there was one of the videos,
Somebody trying to sell us Bitcoin?
no, they were complaining because it was before we got all the new markers.
Ah.
And so we were using the old ones, and there's for